In this video, we are beginning our lesson on chapter 5, which is covering systems of linear equations. This has many applications in business, chemistry, physics, and essentially every branch of education that you would want to study. We're going to begin chapter 5 by looking at the substitution method, where we're solving a system of linear equations involving two equations. But then we're going to get into matrices. This is very beneficial when you have more than two equations in your system. It makes it easier to solve for. But first, in section 1, we're looking at systems of two equations. So to begin with, a system of linear equations is just simply two or more linear equations that are related in some way. Now, we've already seen this in a previous chapter, in chapter 2, where we were trying to find the break-even point. We had the revenue equation and the cost equation, and what we did is we set that revenue and cost equal to each other. That's where we would get that break-even, and we solved for our variable x. And that gave us the break-even point. That gave us the number of items that we needed to produce and sell in order just to break even, to have a zero profit. And so we set these equations equal to each other, and we solve for that unknown variable. And that's that's one way that you can solve a system of linear equations, by setting those equations equal to each other. Now, in this video, we're going to look at a more sophisticated way of doing that, known as the substitution method. There is also the elimination method that you may already be familiar with from a previous algebra class. Now, what we're actually doing when we are solving these systems of equations, looking at it graphically, the solution is where the two lines intersect, right? So if you were to graph the line of one equation and graph the line of the second equation, if you call the first one, say L1, the second one L2, then where they intersect, that is the solution. And that's what we're trying to do when we use the substitution method. When we set those equations equal to each other and solve for x, that gave us the x value where we have that point of intersection. All right, so let's take a look at the steps for the substitution method. Before we do that, going back to the graphing, there are three different possible outcomes you can get when you are graphing. We saw one of them in the previous slide, that these two lines, L1 and L2, can intersect at exactly one point. The two lines intersect at exactly one point. Or at certain times, it could be possible that the two lines in our systems of equations result in the same line. We could have L1 here, and let me just pick a different color. If we were trying to graph L2, it could be that they are the same line. In that case, the two lines are intersecting everywhere at an infinite number of points. And then the third case is that the two lines are parallel and they do not intersect. Okay, so that first case, we say that there is a unique solution. There's exactly one solution. In the second case, we had an infinite number of solutions. In that third case, we have no solution. Now, this is the only three possibilities that we can have when solving a system of linear equations. We can have exactly one solution, or infinitely many solutions, or no solutions, right? Note here that there's no way possible we could get two solutions or three solutions. It's either 1, 0, or infinitely many. All right, now steps for substitution method. That's where we're starting with in the solution of these systems of equations in our section. All right, so you have a system of equations. How do you solve for this using the substitution method? Right, the substitution method, we're going to be substituting one equation into the other equation. All right, so step one, solve one equation for y or for x. It does not matter which equation, and it does not matter which variable that you're solving for, as long as you're solving one of them. So you can choose the easier one to solve for. After you solved for a variable, then step two, you'll substitute that equation into the other equation. That will reduce that equation down to one variable. And so step three, you can solve for that remaining variable. After you solved for x or for y, you'll then substitute that solution that you found into the original equation to solve for the other variable. And your solution is going to be an ordered pair, an x comma y. All right, let's use these steps for solving the system of equations. 3x plus y equal 1, and negative x plus 2y equal 9. Now, I said it doesn't matter which equation that we solve for, it doesn't matter whether we solve for x or y, but I'm going to use that first equation, I'm going to solve for y, because the coefficient of this y is 1. That's going to make it easier to solve for. So if you have any coefficients that are 1, solve for that. And so I'm taking this 3x plus y equal 1, and I'm solving for y. I can do that by subtracting this 3x from both sides. So that's y equal 1 minus 3x. That's my step one. Now my step two, I'm going to take this 1 minus 3x, and I'm going to substitute it into the other equation. I'm replacing this y with 1 minus 3x. This becomes negative x plus 2 times 1 minus 3x equal 9. Now I have an equation in one variable. I have it in the variable x, and I can proceed with my step 3 where I'm solving for x. I'm getting x by itself on one side. Distribute this 2 throughout the parentheses as my first step. 2 times 1 is 2. 2 times negative 3x is negative 6x. Now combine like terms. Negative x minus 6x is negative 7x plus 2. And we'll continue solving for x by subtracting 2 from both sides. 9 minus 2 is 7. And then dividing both sides by negative 7. 7 divided by negative 7 is negative 1. Okay, so I have solved for x. That's x equal negative 1. Now my solution is an ordered pair, x comma y. So after I found my x, I'm then moving to step 4. I'm going to substitute negative 1 back into really either equation, but I'm going to substitute it into the first equation where I have already solved for y. That's going to make it easier to find what my y value is. So I'm going to substitute negative 1 into this y equal 1 minus 3x. So this is y equal 1 minus 3 times negative 1. So 1 minus, let's see, negative 3 times negative 1 is a plus 3. So y equal 1 plus 3 is 4. And so I found my x, I found the y. So the solution to the system of equations is negative 1 comma 4. This is the point of intersection for that system of equations.